Sige. Yes, let's start. So first, we're gonna have to talk about the delete operations. No? So we will start with delete at start, then delete at end, delete at, after a node, and then we will close by search and access. So we will be covering quite a few no? ng mga methods or operations still under our to-do circular linked list. So let's get started. So first, we're going to define our method. So we're going to define delete at start. So since mag-delete naman ta, we will only take self. No? Wala ra tay target data or data nga i-take for this method. So first, it says here that if our head is pointing to nowhere or is not pointing to any node, we're gonna print this error. No? So we've already done that a couple of times last week. If self.head is none, we're gonna print list is empty. And then of course, we're gonna return. Ah, So here, naatay na-mention in the next slide that we have a temporary pointer called deleted data that's pointing to where self.head is, specifically on the data field. So how do we convert that into a code? So we're gonna have deleted underscore data is equals to self.head, and then in order to gain access to the data field, we will have dot data spread. Okay, so we've checked first if empty ba to ang list. If it is, then we're gonna print this error message. And then we've initialized our variable called deleted underscore data, which is pointing to head.data. Okay. Next, we're gonna check if our list, case one, if our list has only one node. We could check that by setting this if statement that if self.head is equals to self.tail, meaning if ang imong self.head is pointing to the same node as your self.tail, then that indicates that it is a single node list. No? So what's gonna happen kung ato ang usara gyud ang node na ato ang nasa tong list, and then kanang only node there would be deleted. So what we're gonna do is we're gonna set self.head is equals to none, self.head is equals to none, and then self.tail is equals to none. So simple lang, kung usara ka node ang naa sa atong list, ato iset ang atong i-reassign or atong i-point si head from the node to none. This would also be applicable to the tail point. Then after that, we will have to print no? Deleted the only node, deleted data. So this is where we can use no the deleted data temporary variable or temporary pointer in the list. So that's if our linked list is or has a single node. No? What if daghan siya of node, just like this example, we have n1, 2, and then 3. So since we're deleting at start, we would be more focused or more concerned with the head node. No? So first, we can have else here first. So unsaon ganito before tayo mag-delete of anything sa ato ang linked list, we're gonna have to make sure that we do not lose any reference of our head pointer. So how do we do that? We're gonna have to traverse. Tapos ang i-move si head pointer from the original head to the next one. So how do we do that? We would have self.head is equals to self.head.next. So kiunsa man pag transfer or pag reassign ni head pointer from n1 to n2, that is through the next pointer. So this is our original head, and then we traverse that to the next one para before ta mag-delete of anything, before ta mo touch of anything for any of our other pointers, we will have to ensure that we have a working node or working pointer for our head pointer. Okay, that self.head is equals to self.head.next. So once na-assure na nato nga naagi hapon tay node nga ka-pointan sa atong head pointer, we will then have to take care of our circular circular loop of our circular linked list. So how do we do that? first, ang ato ang tail currently is pointing to N1. So si N1 man ang ato ang i-delete. Since this, we are trying to delete at start man. So what we're gonna do is atong i-transfer from self.tail.next from N1, we will have to point it to the new no the new head. How do we do that? We're gonna have self.tail.next is equals to self.head. That's simple because we now have ato man gi-make sure gini-move na to daan si head. No? So instead of N1 na siya mag-point, it would now be pointing to N2, which is the new head. Okay, that's for the next field. How about for the previous field? So ang ato ang N2 karon class, which is the new head, is currently pointing to N1. So we're gonna have to fix that. So here we have self.head.prib will now be equals to self.tail. Okay, I hope that's clear so far. So what we did, if in any case our linked list have a multiple nodes. So first is ato sang remove, secure sa nato si head through self.head.next. Now that we have a new head, we're gonna have to reassign or to repoint our tail to the new head. So self.tail.next is equals to self.head. And then self.head, which is currently N2, ang iyang previous no pointer, instead of pointing it to the original or old head, point na siya sa tail. And then once that's done, ato na dahil ito rin ato ang for ato ang result. No? So we have deleted the first node, deleted data, in the list. Okay, so again, if and then of course we're gonna have to decrease our list size. Self.size minus equals to 1. Okay, so just a little bit of a review. Atong check no? If our list is empty, print an error and then return, and then we initialize deleted data na temporary pointer to point to where self.head.data is. Going to our first case, if self.head is equal to self.tail, meaning usa lang to ang node sa atong linked list. Then, we're gonna set head and tail to none, or else, we're gonna set first self.head, move ta sa iyahang next na node. And then, we're gonna set the circular loop. We're gonna fix the circular link, self.tail.next should now be pointing to the new head, and the new head's previous field should now be pointing to the tail. Print and then update the list size. Okay, so let's try to implement the deleted start. Oops, and now remove. Yeah, I'll just lang comment this out. So here we're trying to no, this is insert. So comment this out na lang para play na lang ta, run na lang ta. So we're trying to okay, let me just show you guys the current no. So I have jam, toast, egg, ham, hot dog, yum, and then spam. So if we would have to delete the first node or the head node, then we would be expecting that jam will be deleted in our link. So let's try to run it again. So deleted the first node jam in the list, so we no longer have jam here, and then here as well. Okay, so that's deleting at start. Do we have any questions with the method? Try na. Chapters, sir. Okay, sige. I'll take care of the attendance once or after the discussion. Okay? Okay, wala rin pangutana? Yung padayon ko. So we will continue with deleting at end. So technically, lang siya, mirror image lang siya sa ato ang deleted start. So here, we're gonna define delete at end. And then this would still take self. No? So good old if self.tail It's none. We're gonna print error. List is empty. And then of course we're gonna no. So if our says if self dot head no, sorry, we're gonna have to ano pa, initialize the deleted data. Deleted data is equals to self dot tail dot data, and then we're gonna have to set if self dot head is equals to self dot tail. Then the same lang, we're gonna set head and tail to none. Self dot head is equals to none. Self dot tail is equals to, and then we print deleted the only node, the data in list. That's our first case, no? Else, magyapa itong buhaton, mag-start ta sa tail. So here, we're gonna check self.tail is equals to self.tail.prep. So just like what we did earlier with deleted start, we're gonna have to secure our tail pointer. So we're gonna have to transfer it from N3 to N2. That's going to be through the tail.previous field. So now that we now have a new tail, we're gonna have to fix our circular link. So how do we do that? We're gonna have self.head.priv is equals to self.tail. No? Dato ang self.head.priv is currently pointed to N3. N3 man itong i-remove, so we're gonna have to redirect that or repoint that to another. So muna naman itong new tail. So we're gonna have to do that to reassign our self.head.priv to the new tail. And then after that, our self.tail.next is also currently pointing to N3, so we're going to have to fix that. Self.tail.next would now be equals to self.head. Right there. So self.tail.next would now be equals to self.head. And then that should then remove or delete the node at the end. And then we're going to have to place deleted the last node, deleted data in the last. And then of course, let's not forget to update our list size. Okay, so what did we do? First, check yapon if list is empty. Initialize deleted data through the original tails data field. And then first, we're gonna check if head and tail are the same node. Then we're gonna delete the node by setting head and tail to none. And then identify the new tail by using self.tail.prev. And then we're gonna update the circular link. So from head to the tail, and then from the tail to the head. And print, and then update the list size. Okay, question with delete at end. Pangtana. All clear? All good? Okay. Ay, ato sa siya i-implement ako lang sa siya. I-try ako lang sa siya. I-demonstrate. So we currently have spam as our last node. So how about if I just in here, delete at end. So deleted node spam in the list. So wala na tayo spam. No? Naluto na siya. So na. Okay? Sige, let's proceed to deleting after a node. So deleting after a node that is quite is quite loaded. Right? Again, dagdag ka edge cases, dagdag ka ipang consider ng mga use cases. Okay? So here, we're gonna have define again. Define delete after node. So this time, since we will have a target data, so we're gonna have self and then target data para adto na at siya ato ang point para dito ta mag-delete after niya. Okay? So here we're gonna set if head is none, we're gonna print an error that stops. So if self.head is none, we're gonna print error list is empty, and then we're gonna return. And after that, we're gonna set temporary pointer called target node to self.head. So target node is equals to self.head. And then just like last week, we used a flag found found, and then we default that to false. And then right after that, we will then get into our infinite loop. No? While true, we're gonna check if target node.data is equals to our target data. And if it is, we're gonna flip the value of found from false to true, and then we're gonna break the loop. And then if dili gani pa siya, if dili pa ni siya masatisfying condition, we're gonna have to traverse. Target node is equals to target node dot next. And then if na humana niya ang cycle, humana niya traverse each of the node, if target node is equals to self.head, we will have to break. Okay, so humana niya siya. If target node returns to head, we will then have to break the loop. And then going outside of our while loop, if not found, meaning ang ato ang found value is still false, obviously kaya wala man ito siya okay, so we're gonna have to print an error, no? So we would have error target node target data is not found in the list. And then of course, we're going to turn. Okay pa ta so far? This is the algorithmic outline. I'm sure that we've already gone through this same logic before, no? With the insert after. Pero dire na matter. So here, we're going to initialize more temporary variables. So here, we would have a node to delete. No, this is a temporary variable to would always be where the next node of the target node. So target node dot next. O siya masigig sunod sa ato ang target node dot next. And then we would have to extract the data. So we're gonna have to have say deleted data is equals to node to delete dot duha na ka cases ang atong i-consider when we would be delegating, specifically at start. So here we're gonna check if node to delete is equals to self.head. We're gonna have to call self.delete at start, and then we're gonna put it. So deleted the head node. Sorry, this is deleted the only node. Sorry. Deleted data of the list. And then of course, we're gonna return. So naana siya if ang ato ang node to delete, sorry, if node to delete that head, this is actually to the head node. So if ang ato ako ng node to delete is pointing to the head node, then of course we would have to delegate it to an existing method called delete at start. And then the print here, deleted the head node, since it's currently also pointing to where self.head is of our list. So that's one. This is number 2 na pala na. So if node to delete is the target node, so if node to delete is equals to, this is double is equals to the target node, Meaning ani niya class usara ang um atong node. So we will then still self dot delete and start. Then we're gonna print deleted the only node, deleted data of the list. Then of course we're gonna be so again, these are the two conditions or use cases, edge cases, where we will delegate to an existing method called delete at start. No, yan naman na diri. Ito ang delete at start. Okay? Questions so far before I proceed or clarification. Sa ito ang delete after a node. Lara? Are we all good so far? Are we on the same page so far? Hello, naapat na diha? Two at
Yes, sir.
least. Okay, sige, sige. Thank you. Padayon ta. So here, that's when we delegate no, to delete at start. So the third one is that we're gonna have to delegate the tail. So if ang ato ako nung if node to delete is equals to self.tail, meaning kung ang node nga ato ang i-delete is pointing to where self.tail is ato isibog. So self.tail is equals to the target node. So meaning nga niya class is that if ang ato ang node to delete is pointing to where the tail also is, then the self.tail will now be pointing to where target node is. Okay, ang node to delete is the one that we're gonna delete. So we're gonna have to isibog na to i-secure si self.tail. Just like what we've done with delete at end na method. Okay? So here, we will then have to fix or relink our pointers. So here, we're gonna have target underscore node dot next is equals to node to delete dot next. We don't have to worry. We will have visualization right after this. And then node to delete dot next dot priv is equals to the target node. And then node to delete dot next is equals to none. Node to delete dot priv is equals to none. And then we're gonna update self dot size minus equals 1. And then we're gonna print deleted node and then the deleted data node after our target data. Okay? Okay, let's try to visualize each of these lines. So first, of course, the infamous if self-dot is none, we will print an error. So karon na atay temporary variables of temporary pointers called target node, which is pointing to where self.head is. And then we also have found flag, which has a default value of false. And then after that, we would enter our infinite loop, the while true loop. So if our target data is ham, we're gonna have to check no, if target node.data is equal to target data. Atong i-switch si found to true and then break the while loop. But if dili gani traverse. So is target node.data egg equals to target data ham? No, it's not. So mo traverse ta. Is target node.data ham equals to target data ham? Yes, it is. So we would have to flick or to change or update the value of the found flag from false to true. Then we will break the while. Okay. So if in any case, say for example, ato ang target data is say jam. So false, kuan gyapon siya not equal siya. So, he should traverse up until mabalik siya sa self.head. So when siya, if target node is equal to self.head, we will have to break the while loop. And then if not found, meaning if atong found is still false, then we will print the error. So target node, our target data jam is not found in our list. Okay. Then Ayan, mo na siya itong print ang error message. Karon, we now also have another temporary pointer which we call node to delete. So our node to delete pointer is always target node dot next. So kung si target node nasa N1, the node to delete is in N2. And then we have to extract no, the data field of our node to delete. So we store that in deleted data. So node to delete dot data. So one use case here, if our node to delete is equals to the target node, hindi rin lang ako mag-start. So if our node to delete is equals to target node, meaning na niya usarang ang ato ang node sa atong linked list. So we will delegate this to delete at start. And then we print deleted the only node in our list. Okay. And then the other use case here is that if our node to delete is equals to self.head, for example, um, we have here our target data is say it's host. No? So next man ani niyang node is the head. So if ang target node is the tail, imong node to delete is the head, then your N1 will be deleted. So target data host, then it should be delegated to delete at start. Okay? And then lastly, if ang ato ang do you call this? Our node to delete is equals to self.tail. What's gonna happen is that atong i-move ang ato ang tail nga pointer. So currently it's in N4. Nawala ang akong tail dito. So N4 is currently pointing to tail. So since we would be when we would run delete after node, then ma-move na si tail to N3. Okay? So that would be that. So let's go back to our delete after node. So for example, our target data is ham. Our target node is ham in N2. So our node to delete will be N3 or the spam node. So what we're going to do here is target node.next. Target node.next is currently pointing to N3. We will be pointing that to node to delete.next, which is N4. And then node to delete dot next. Node to delete dot next is N4 dot prev. Sorry. Okay. Dot prev here, which is also currently pointing to N3, will now be pointing to the target node. Ako sa inaog para mas klaro. So node to delete dot next is currently pointing to N4, so ito siya unlink equals to none. And the node to delete dot prev is equals to none. And that should remove our node to delete or N3. Okay, and then update the you'll call this the size, and then we're gonna print deleted node, say spam after ham. Okay, any questions with the delete operations or clarification? Rana? Yes, Ralph, go ahead.
Ay, paano sir? Kano ako sir? Present sir. Sorry sir.
Okay, sige, sige. Sige, I'll continue ha. So, with... Ay, wait, I have not... So, currently, we have toast, egg, ham, hot dog, and then yam. So, let's try deleting after a node. So let's try removing hot dogs. Let's have ham here. Okay. So let's try. Okay. What? Okay. Delete after. And then once we run the code, so we deleted node, hot dog after ham. Okay, just give me 1 second.
sure. Oh, magpa-print niya ko nimo. Wala.
Ah,
Na mapalit na ko ilang kuan.
okay.
Okay
So
niya.
yeah, that's our deleting after a node. So let's continue with the next operation. So we only have two more operations, huh? So let's start with searching by data. So here, gonna have to define search, and then we're gonna take self, and then our target data that we're trying to, of course, search. So basically, this would return the index value of the target data that we're trying to search in our linked list. Okay. So here, of course, if self dot head is none, no, if self dot head is none, we're gonna print error, list is empty, and then we're gonna return. Okay. And after that, we're gonna set our current pointer to self dot head. And then we would also have to initialize index to 0 para siya mag-monitor kung kapila na ta nag-traverse through our linked list. So here, we're gonna check, no? We're gonna enter to our while loop. Here, while true, we're gonna set if current.data is equals to our target data, we're gonna have to print diretso, no? Search for our target data node found at index and then provide the index value. Then of course we're gonna return current. But if dili gani, the same logic sa ato ang delete after node. If dili siya equal, current is equals to current.next mo traverse ta. However, the additional logic here that index while we traverse will be incremented by 1. So sige siyang traverse magkataas pud ang values ato ang index. So once mulapas na pud siya, we're gonna set if current is equals to self.head, we will then have to print target data is not found in the list. And then we're gonna break our file. I'm sorry, ano ni siya, another, see, redundancy. So we'll just have to break. Kay if wala gani gid siya, this is where we would print. Eh? So we'll have search for target data node not found in the list, and then we're going to return none. No, so let's try to visualize this. So while true, so our target data is spam. So here we're going to check current.data egg is equals to target data spam. No, it's not. So we're going to have to traverse. So while we traverse, we've added 1 in the value of index. Current.data ham equals to target data spam. No, it's not. So we're going to traverse. So current.data spam equals to target data spam. Yes, it is. So we're going to go ahead and print, no? Search for target data spam node found at index 2. Okay, say for example, let me try to sige, ham gihapon natong i-search. Ayam, dito. Yeah. Hanap ito. Ham. Okay, so let's try running the code. So search for ham node, we found out at index 2. How about yum? So it's at index 3. 0, 1, 2, 3. Okay, so that's for searching by data. How about if you will try to access, no? By index. Diretso na lang tani. Accessing by index. Okay? So we will then define access by index, no? This would take self and then our target index that we're trying to access. And then this would return the data, no, of the node that we are trying to index. So of course, next is if self.head, the same. If self.head is none, we're gonna print error list is empty and then return. And then here, class, we're gonna have to check, no? Remember last time sa ato ang doubly linked list, there were three um, parameters that we were gonna have to pass through pa before we could proceed. So here, if target index is less than zero or target index is greater than or equal to self.size, we're gonna have to print an error gihapon, no? So, for example, um, target index is out of bounds, meaning lapas siya, dili ta maka-accommodate sa ato ang target index kay uh, it's either less than zero siya or greater than or equal siya sa ato ang list size. So let's explicitly put here our self.size para makaibaw gyud si user kung unsa lang range of target index ang pwede natong ma-access sa kanina linked list. And then we're gonna return. That's that. So last time atong merge ang tulo ka kuan parameters if self.head is none or if target index is less than 0 or target index is greater than or equals to self.size. So mo na siya tong gibuhat last time, just a little bit of a refresher. So karon target index nato is 0.2, so less than less than 0, so error ta. Index 0.2 is out of bounds. List size is 4. Atong target index is 6, atong self size is 4. So, error pud siya. Atong target index is 4, which is also equal to self.size, lapas siya. Because our maximum target index should just be self size minus 1. No, mag-start ng tag 0. Okay, next. So we're gonna go ahead and initialize our current variable. So current is equals to self.size. And then we also have the count variable. So count is initialized at 0. And then we're gonna go get into our infinite loop. Na kung while count class is less than our target index, we will have to traverse. So sige tao and transfer or go next to our next node. So current dot next. And then while we do that, just like with our search, we're gonna increment the value of 1. So here, let me just add the print first. Para diretso na ta accessed index target index found this is not early braces current dot data node. I know okay, and then of course we're gonna return current. Okay, sige, let's try to visualize. So our target index here is 2. Our count is 0. So while count is less than target index, we're gonna traverse. So count is equals to 0. Count is less than target index. That is true. So we will traverse. So count is now 1. But count is still less than target index. We're gonna continue traversing. This time, count is no longer less than target index. So we will break out of our while loop. And then we will print our report or our output. So access index 2, we found the spam. Okay, so let's try to implement this. So for example, sige, ano lang nagamitan dali. So when we run, current dot next. Current is equals to current dot next. Yan naman eh. Wait lang. Maybe I'm out of That seems to be correct. Give me 1 second here, huh? Target index is would be CLL next access by index. Access by index. Target less than zero. Target index. Current is equals. Sorry. Current is equals to. Sorry, not self dot side. This is self dot head. Okay. Let me try to run this. So that should be and access index 3, we found the yum node. So 0, 1, 2, 3. And then access index 1, we got the egg node 0, 1. Okay. So that should be it for our Jubilee circular linked list. Do we have any questions? Pangutana, clarification. And let me just make sure be that you have a copy of this for you guys to ano, to play around. Ako sa i-add sa atong class notebook very quickly while you guys think of your questions. Content library. This is Jubilee circular list. And then I'm gonna distribute this page to everyone. Okay, while it's distributing, let me take care of the attendance. Give me 1 second. So I have Bakulpo, Papuyan. Okay, and Sepi. Late na pud ka, Sepi. Ay, nako. Hindi na lang ni siya kalito. Okay, so class, I just want to let you know that this would be the last discussion that we would have for the semester, no? So then ni hara si Francis. Okay, sorry. So this would be the last discussion that we would have since this would be our final topic naman for the semester. Pura buyag mo gid taon natong na-cover, no, with all of the things that have happened for our semester. So bago ako join those. Sige. Sige basing. Sige. So we have let me just check. Okay, kindly check your class notebook for our Sabina sir. Okay, sige, so what's gonna happen this week is that okay. So for this evening, I will have you guys work on a worksheet, no? Actually, kanisiya is supposedly in our next meeting, pero apiki naman. So ano na lang siya, mura ni siya og an opportunity for you guys to to apply what we have learned in our delete operation. So basically, this is just an extension of our worksheet number 15 since insert raman to nga mga methods or operations nga to ang i-apply. This time in worksheet number 16, mag-implement na tayo sa delete ng mga operations still in the context of music player. Okay? So ito nang i-assign tonight para you could apply and play around it. And then you can submit that before before our session on Wednesday. Ha? Wala, dili na kayo na siya kayo. Apiki naman sad wala sad may dedicated nga time to work on that particular worksheet. However, on Wednesday class, we will have our final examination for lecture. So dali ra na siya, pen and paper lang. So I would be asking you to prepare the following. So number one, a white uncrumpled long white bond paper, ha? So dili lang siya gumos palihog ang ato ang bond paper kay para na siya sa ato ang solution kung ganahan ta mag-draw sa ato ang mga nodes sa atong solution ana siya. And then 2 pesos for the photocopy sa ato ang test paper. So back to back naman siya. So test 1 will be multiple choice. Test 2, um, code tracing. And then test 3 will be pseudocode or algorithmic outline. So any of those operations, ato to i-plan dito to really assess how far we've learned and internalized the operations. Okay, and then by Friday, we will have our laboratory examination. So kindly bring your devices. Please do not forget to bring your devices para dito ta mag-code. So mini project gyapon siya. Okay, so you will be provided with a paper para dito na ta mag-check sa ato ang saan assessment. Dili na ta kailangan ng internet, dili na ta kailangan mo-open sa ato ang messenger or anywhere. So dili na kailangan ng internet. Okay? So also, the top 3 katoto ang check-up quiz. By the way, the top 3 will be exempted sa test 1 for our lecture examination. Okay? Sa itong top 3, you guys are exempted. For lecture. Sige, do we have any questions? Give me 1 second. Wait lang. Wala na question? Sige. So if there are no questions, I have already shared with you guys the code snippet for the entire doubly circular linked list, and then kindly use that as your study guide, no? Together with the doubly linked list as our pointers for the final examination. Okay, thank you so much everybody for attending this session. I'll see you guys on Wednesday. Okay? Thank you very much. Mag-amping ta kanunay. Goodbye.
Bye-bye, sir.
Bye-bye.
Bebe, ay si group lang sa Bebe.
Okay.
ko katapang sa kutres, ate sa kuhan ko kutres, kaya ko.
Oo.
Kaya yung tingpan. Okay, lumulugay ko.
On sa inyo kanon, magtuna lang ko.
Magtuna 1,000 siya. Magpalit na ako sa bang. Ay, magsabinas lang din ko. Ito ka nagtuna. Tingnan ko kayo mag-usap. Ang suga pala itong buwana. Kaningay, baka kayo sa kuwansa. Mariana, kaningay, baka no kayo.
Asa, asa.
Dira sa kuwansa na.
Wala ito. Busy ka, Han.
Unsa na kayo, Sogo?
Oo, nakatapos pa. Tapos yung mga
Bebe.